Okay, so we have a graph of a quadratic function, right? We have intervals of the x-axis. Now the graph, it's a quadratic, and it continues, and then it starts back up. If it's a depth versus time thing, of course, the domain just kind of stops right here, where things stops decreasing. But we have intervals of the x-axis, so for those intervals, we get points on the graph. You know, for the endpoints of the intervals, we get points, and you're used to that. I think everybody did pretty well with that. And then we get fundamental triangles. And what do fundamental triangles have? What do you label in a fundamental triangle? Rise, run, slope, midpoint, hypotenuse, length of the hypotenuse, right? Add up, you know, do fundamental triangles all along this thing and add up the lengths of the hypotenuse, you get how far you have to travel along that curve. Okay? I'm not going to ask you that. Probably will at some point later, because it's kind of an important thing, you know, how far do you travel if you go around this curve and stuff like that, okay? Follow the path, how far is it? But that's one thing we haven't worried too much about, except you're supposed to label it unless I say you don't, right? But we have the slope of the first triangle and midpoint of the first triangle. Let's just number these intervals. 1, 2, 3. So if I give you these intervals in the function, you're going to be able to do that. Okay? Y'all did real well with that. Okay? Where you got, on the homework, yeah. Where you got confused is what does it mean to graph the slope versus the midpoint x value, right? But, okay? Well, you got 3 slopes, right? So you make a table. And in that table, you put your first slope. Then your second slope. And the third slope. What do you put down for your midpoint x? Now you've labeled these triangles. Can you read off your midpoint x value? So, I'll call midpoint 1, the midpoint of your first triangle, right? The x-coordinate of the midpoint 1, that's the x-coordinate of the midpoint, right? Then you draw a graph. Slope goes here. Abbreviate midpoint with just midpoint x, right? Okay? And we get 3 slopes. Actually, notice all the slopes are negative, right? So we got mid x1, mid x2, mid x3, and we got slope 1, slope 2, slope 3. For this curve, will the points look like this? If we go from the first interval to the second to the third, do the midpoints increase? midpoint coordinates increase? Well, x increases in this direction. The midpoint coordinates are just, the midpoint here, the midpoint here, and the midpoint here. So we just actually take a copy of this thing and slap it down here, and we'd have our x-axis with the 3 midpoints. Okay? So the slopes look like this: slope 1 down there, slope 2 higher, slope 3 higher, but all below the x-axis, or the horizontal axis, the x-axis in this case. Well, yeah, that's a negative slope, right? And this is a negative slope, and this is a negative slope, right? And which negative slope has the bigger magnitude, the bigger number? This is a bigger negative. It's actually a lesser number, but the size of the negative is bigger, right? So it means this is further below 0 than this is and this is. These things are getting closer and closer to 0, aren't they? And that's the way these slopes go. So we draw the points. So we have a point here, and we have a point here, and we have a point here. Do those points lie on a straight line? Turns out that for a quadratic function they do. Okay? Then I ask you questions like, okay, what does this graph mean? What's the slope mean? If this is depth versus clock time, what's the slope mean? Well, you should understand, slope always represents a rate of change. It's the rate of change of depth with respect to clock time. So it's how fast depth is changing, right? Now depth is changing. It's always negative because water level's going down, right? So what does it mean at the point where the straight line through these points, if you do everything right, if the straight line hits the x-axis? What's that tell you? What's that tell you about the slope? At this point, what's the value of the slope? Give you a hint. Slope's on this axis. It's 0, right? Slope is 0. So the rate of change is 0. That's the rate of change of depth with respect to clock time. Which means what's happened? Means water's not flowing out anymore. At that instant, up to this instant, it's flowing out. If this is accurate, okay? After that instant, it's not flowing out. Well, how does that relate to this graph? Water stops flowing out, so this x value should match this x value. Okay? Does all that halfway make sense? Talk more about it on Thursday. If you understand that much and how to do these graphs and everything, then you're going to be in good shape. Okay?